Hello, our project title is a simulation of solar wind hybrid power generation for electrical vehicle. And our project students are Garud Akash, Shinde Aniket, Unale Aditya, Wagmare Saibra, and myself is Aniket Shinde. These are the component of we include in my PPT. First is proposed similar title, introduction, objectives, block diagram, design of PVRA, 6 number 8 design of DC to DC boost converter, MPPT controller. In that MPPT controller, two algorithm, piano algorithm and incremental conductance algorithm, and conclusion and references. Introduction. Solar and wind hybrid power generation is the innovation of the suitable approach to the producing electricity by the combination of the strength of solar and wind energy technology. This hybrid system harness of the power, sun and force of the wind generation electricity, providing a more reliable and constant energy supply compared to the standalone solar wind system. These include the explore and key component benefit of solar and wind hybrid power generation. Objectives: to study of model of PV cells, PV array and PV panels. Second number is just to study of characteristics curve of effect variation of environmental condition like temperature, irradiation on them. Third point is the to study of PV model behavior under. Fourth point is the to track the maximum power point operation of PV panel irrespective of the change in environmental condition. Fifth point is to study of simulation to solar power system of tracking maximum power point. And next block diagram is hand over to Akash Garud.
This is the block diagram of our project. In block diagram we have wind turbine. The wind turbine outputs are in AC and we need the converter AC to DC converter. The further connections of converter are given to the bus bar, and from the PV array radiations it is our output in DC and we need DC to DC, but we need in set limited, so we have the DC to DC converter which is buck or boost. Further the bus bar connections are given to the controller. In controller we use MPPT controller which is maximum power point tracking controller. The secondary connections are for battery which we need for a backup, and from the controller we need an inverter and from inverter we have given the connections to the load which is our electric vehicle.
This circuit diagram of PV array. In this, we see that the radiation fall on this PV array, and this current flowing from this is called as photovoltaic current, and the current which is flowing from the diode is called diode current, and this is the shunt resistance, and the current flowing through this is called as shunt resistance, and this is a series resistance, and thus we get total amount of current I, and we get output of this circuit is called as voltage V. About this PV array, we get mathematical modeling equation such as saturation current, reverse saturation current, current through shunt resistance, photo current, and output current. These two graphs shows the output of this is the output of PV array. We show the IV characteristics, and this is show the PV characteristics. As in this, as voltage increases, the current also increases up to this point. This is called as MPPT, and after that the current start to decrease as we increase the voltage, which is called, this is also called as saturation point. And in this shows the graph of PV array. This point is called as the MPPT point, and after this point the graph decreases below, which is called as saturation.
Here we have the DC to DC boost converter circuit diagram. In this circuit diagram, when the our voltage is input, we use inductance and further diode, and then it is given to the load. From this inductance and diode, which is the set limit or the rated limit DC voltage we get in that point. This is our DC boost converter simulation. Here we have input voltage, and from the diode and across voltage across inductor, we get the output voltage through inductor current, capacitor current, and load current. The results of DC to DC boost converter are constant, which we need, that is from our according to the rated voltages.
This is the MPPT controller. In that MPPT controller, there are two algorithms. First is a piano one, and second is a incremental. This is the piano. In this piano, it is not a actual voltage given, and this is the simulation of the piano, and this is the output of the piano. Or this is the output voltage, and this is the product, and this is the output voltage duty cycle, and this is the result of output voltage, output current, and output product. And this is the incremental conductance of algorithm. This is the simulation of the incremental conductance. There are the temperature or radiation. Temperature is a 20 degree, or radiation is 1000. Here is the output voltage and output current, and this is the simulation of output voltage. This is the without MPPT. This is indicated in yellow line, and output voltage of incremental conductance is indicated as blue line. This is the there is a voltage is above, power is 200. This is the power is 240 above, and this is the, I think, 40, nearby 40. So incremental conductance is good for our project. Accuracy is a more than piano. More than piano, incremental is a more accurate than piano. Application EV charging, business, large instant houses, factories and manufacturing factories, commercial power generation, street light. Futures को increase the energy demand, energy transition, technology advancement, energy storage, grid integration, hybrid with other energy resources, a macro grid
In this project, we have learned that by this project many villages can be enlightened. For villages which are away from the construction site of large power generating stations such as hydro and nuclear, and can be provided power. Also, to satisfy the increasing demand of electricity with clean hybrid power stations by solar, wind can be used. For example, the remote areas like Konkan and Dehradun places we can enlighten with this project, and also we need to use it in where we have both the resources available such as PV radiations and wind sources. Thank you.